Hello everyone. In this video, I will discuss about failure mode effect analysis. This is Asif Biotech. Why is so important the failure mode effect analysis to eliminating the problems and identify for the purpose of preventing undesirable event. Let's get started. Failure mode effect analysis FMEA is the procedure in the product development or operation management for analysis of potential failure mode within the system for classification by severity and likelihood of the system. Means ये जो सिस्टम है, ये जो फेलियर मोड इफेक्ट एनालिसिस है, ये एक तरह का सिस्टम है जो कि किसी भी ऑर्गेनाइजेशन में नए प्रोडक्ट लॉन्च होने से पहले इस चीज़ को रेडी करते हैं, इस तरह का डॉक्यूमेंट्स रेडी करते हैं जो इस चीज़ के इवेंट को प्रिवेंट करे, फेलियर मोड को. ओके, एंड फेलियर मोड्स आर एनी एरियर और डिफेक्ट in the process, design or items, especially those that affect the customer and can be potential or actual. Effect analysis refers to studying the consequence of those failure. Main terms we should know about what is failure mode, what is failure effect. First we understand what is failure. Failure is the loss of intended function of device under state conditions. Failure mode. What is this failure mode? Failure mode is the manner by which a failure is observed. It generally describes the way the failure occurs. Failure effect. Failure effect, immediate consequence of the failures on operation function or functionality or status of the some items. Failure cause. Failure cause is the defect in design, process, quality, part of application, which are underlying the cause of the failure or which initiate the process which leads to failure. Failure cause might be in the problem in the defect in the design, process and parameters, might be anywhere will be problem with it, that is the failure cause. And severity consequence of the failure mode, that is severity. It considers the worst potential consequence of the failure determined by the degree of injury, properties damage or system damage that could ultimately occur. Severity is just a consequence of failure mode that is represent the consequence of failure mode. It might be degree of injury, properties damage or system damage or that ultimately occur. Okay, and process for conducting the FMEA is typically developed in three main phases. Failure mode effect analysis will categorize in three steps. First step is severity, second step is occurrence, third step is deductions. We will discuss one by one in details. First we understand what is severity. Severity, it is the condition where the determine all failure modes based on the functional required and their effect. Example of failure modes are electrical, shortening, circuiting and corrosions or deformation, or shut down any process. Or failure mode in one component can lead to failure mode in the another components, therefore should be the listed in technical terms or for functions. Thereafter the ultimate effect of each failure mode if needs to be considered. A failure effect is defined as the result of the failure mode on the function of the systems or perceived by the users. Example of the failure effects are degraded performance, noise or even injury to a user. Each effect is given a severity number. Each effect is given as a severity number, means how much severe that case, how much serious that case means, we can say like. And from 1 to 10, 1 means that is no danger, 10 means very critical case, and those number have to an engineer prioritize the failure modes or their effect. If the sensitivity of the effect they has the number 9 to 10, means action are considered to change the design by eliminating the failure mode if the possible are protecting the user from the effect. Means if the severe number came the 9 to 10, it means there is the biggest problem in the process, we have to change the something in the process. And when we talk about the rating of the severe, how much, like rating 1 means that one no effect, rating 2 very minor, only noticed by the discriminating customer, 3 minor, affect very little or the system noticed by the average customer, 4 5 6 moderate, and 7 8 high, loss of primary function, customer are dissatisfied, 9 to 10 is a very high or hazardous product becomes inoperative, customer angered, the failure may result unsafe operation or possible injury. When we talk about steps 2, occurrence looks at the cause of failure mode, the number of times it occurs, means how many failures can happening in the systems, that is called occurrence. All the potential cause for the failure mode should be identified and documented in the technical terms. A failure mode is given an occurrence ranking 0, occurrence ranking 0 again 1 to 10. It means as a severe 1 to 10, it's 1 it means something meaning like that, and 10 it might be the higher critical case. This step is called the detailed development section of the FMEA process. Occurrence also can be defined as a percentage if the non-safety issue happened less than 1. If any non-safety issue, if the no safety issue happened less than 1%, we can give 1 to it based on your product and customer specification. Meaning rating, when we give the occurrence rating, 1 means no known occurrence on the similar product or process, 1 to 2 low, relatively few failures, 4 5 6 moderate, occasionally failure, which means the repetitive failure, 4 to 7 to 8 high and repetitive failure, 4 to 7 to 8 it is repetitive failure, 9 to 10 very high, a failure is almost inevitable. Deduction. First, an engineer should look at the current control of the system that prevent the failure mode from the occurring or which detect the failure before it reaches the customer. Identifying, testing, analysis, monitoring or other techniques that can or have used on similar product, similar system to detect the failures. Likely lines for failure is identified or detected. Each combination from the previous two steps receive reduction number. This ranks ability of the plant, test or inspection to remove defect or detect the failures mode in times. Assign reduction number. Reduction number measure the risk that failure will be escape reductions. The high reduction number indicate the chances are high that failure will be escape reductions, or even other words that chances of the reduction are low. Deduction, it means it is indicated like there's something alarm where the something failure is going on. Rating for deductions, and how much rating 1 certain fault will be caught on test, 2 almost certain, 3 high, 4 5 6 moderate, 7 8 low, 9 10 fault will be passed to customer undetected. Risk priority number, RPN. Risk priority number is an important part in the choice of the action against the failure mode. There are threshold value in the evaluation of these actions. RPN can be easily calculated by multiplying the severity, occurrence or detectability. RPN is the multiply by severity, occurrence or detectability. This has to be done for entire process or design. Once this is done, it is easy to determine the area of the greatest concern. This failure mode that have the highest RPN should be given the highest priority for corrective actions. If the high number of the RPN is came, which means we need to corrective actions, we have to immediately correct action. This means it is not always the failure mode with the highest severity numbers that should be treated first. There should be less severe failure but occur more often or less detectable. FMEA should be updated whenever a new cycle begins, when the new product is started, that is applicable. Chances are made to be operating condition, changes in the made in the design, new regulation are instituted, customer feedback indicate or problems. We have to apply on these query. Types of FME: failure mode analysis, failure mode effect analysis, process analysis of the manufacturing and assembling process, design analysis of product period to production concept, analysis of system or subsystems in the early design concept stage, equipment analysis of machinery equipment design before purchase, service analysis of the service industry process before they are released to back to the customer, system analysis of the global system function, software analysis of the system, analysis of the software function, which means the types of failure mode effect analysis where will we come there. What is the use of this? Development of the system requirement to minimize the likelihood of the failure, development of the method to design test system to ensure that failure have been eliminated, evaluation of the requirement of the customer to ensure that those do not give rise to potential failure, identification of certain design characteristics that contribute to failure, minimize the eliminate those effective, and tracking managing potential risk in the design. This help avoid the same failure in the future. If any failure will become in the future, we can detect the problems by previous data. This through what is the advantage? Improve the quality, reliability, safety, product process, and improve company image or competitiveness, increase user satisfaction, reduce system development timing and cost, collect information and reduce failure, capture engineering knowledge, reduce the potential for warranty concern. That is the main advantage is here. Improve company image, competitiveness, early identification, elimination of the potential failure modes, emphasizes problem and prevention, minimize late changes or associated cost, reduce the possibility of the same kind of the failure in the future, reduce the impact of the profit margin company, reduce the possible scrape in the productions, ensure that any failure that could occur will not injure and the customer seriously impact a system. To produce world class quality product, we can produce definitely world class product. Thank you for watching this video. If you like this video,